Well, we're back and we're going to look at a couple of problems in which we're computing expected value. And this is the end of section 5.2. So the first problem is we have 1,000 raffle tickets at $1 each that are being sold, and the prize is a color TV valued at $350. What is the expected gain if you purchase a ticket? So let's think about that a minute. If you're buying a ticket, what do you expect to gain? So we're going to set up a probability distribution for this. So our value for X, with these kind of problems, I kind of want to think of it as either you win or lose. Okay, so I'm going to put win and lose as categories up here above this. And then we need the probability of that occurring. So you buy a raffle ticket. And if you buy a raffle ticket, how much do you win or what do you win? Well, you win this prize TV that is valued at $350, but you spent $1 on the ticket. So really, how much are you winning? Well, you're actually winning $3.49 because you bought the ticket for $1. Now, how many winning tickets are going to be in those 1,000 that are in the raffle? Just one. So the probability that you win is going to be 1 out of 1,000. Now, suppose you buy a raffle ticket and you don't win the TV. How much did you lose? Well, the cost of the ticket was $1, so you're losing $1. And to indicate that, we're going to use a -1. And what's the probability you lose? Well, if the chances you win is only 1 out of 1,000, then losing is the complement to that, which is 999 out of 1,000. So you have to kind of visualize those 1,000 tickets sitting in the pot, one winner. So this is our probability distribution. So when we get ready to type this into our calculator, in list 1, we're going to put our X values, and in list 2, we're going to use the probabilities. Now, to save a little bit of time over here on my calculator, I've already typed those in. So I've got, well, I have them in reverse, -1 and 999 and 349, and that's 1/1000. And once we get them typed in, then we just go to Stat, arrow over to Calculate, var stat on those two lists, list 1, list 2. And remember now, if this screen's not showing up, you're typing in L1, L2. And when you enter, what we end up with here as X bar in this problem is -65, -65 cents. Or another way of looking, well, that's not X bar, right? Because with a probability distribution, what's the mean always going to be? I know it shows up X bar on our calculator, the mean is always a parameter. So it's mu equals -65 cents, or the expected value of the random variable X is a -65 cents. Now let's think about that a minute. If this charity is selling 1,000 tickets and the people buying the tickets are expecting to lose 65 cents each, and they spent $350 on a TV, and they're buying these tickets for $1 each. So they collect, the charity collects $1,000, but they had to pay $350 for the TV. Okay, so as we're kind of thinking about this, that means they're really only going to make $650, which means they're going to make 65 cents per dollar ticket bought. Well, if the charity makes 65 cents per dollar, then the people who are playing the game are going to lose 65 cents per dollar ticket that's purchased. Kind of just to see it as a big picture thing. Okay, moving on to our next one. This one, we have a financial advisor that suggests that his client buy one of two types of bonds, and the client has $5,000 to invest. Well, bond X pays a return of 4% and has a default rate of 2%, while bond B pays a return of 2.5% and has a default rate of 1%. Find the expected rate of return for each type and which is a better investment. Well, let's think about this a minute. This person has $5,000 to invest, and in bond X, he can either make money, get a return of 4% on his investment, or he could lose everything. That's what I mean by default rate. And the default rate on that particular bond is 2%. So if we set this up as a probability distribution with X and probability of X, he's either going to make money, I'm going to still say this is like win, or he's not. He's going to lose everything. So for bond X, if he makes to make money, what is 4% of $5,000? That's the amount that he can make. So 4% of 5,000 is $200. I'll check my arithmetic here. So he could make $200 if he invests his $5,000 here, or he could lose all of his money. If he loses it, he loses $5,000. That's a negative $5,000. Well, the probability he loses all of his money is 2%. So that's the probability that goes here, 2%. What's the probability then that he's going to make money? Well, these two have to be complements of each other. So if 2% of the time he loses, then 98% of the time he should be making money. And here we've got our setup for that particular problem for list 1 and list 2. Now, bond Y pays a return of 2.5%. So I'm going to set this one up sort of the same way, except instead of calling this X, I'm going to call this random variable Y and the probability of Y. So either he's going to win or he's going to lose. So let's look at what happens here. He makes a return of 2.5%. So if we take 2.5% times $5,000, that's going to give us $125. So with this particular bond, investing $5,000, he could make $125. And here again, it could default, and he might lose everything. But if he does, he'll lose his $5,000. But the difference is the default rate here is 1%. So the probability he loses all $5,000 is only 1%. Well, what does that mean? The probability he wins or makes money? That's going to be 99%. And we want to calculate the expected value for these two bonds. So I'm just going to do X and I'll leave Y for you to do. But for the X, we're going to go back over here to our calculator and go to Stat, Edit, and we're going to clear both of our lists. And in list 1, we're going to say that, well, he could make $200. Or he could lose 5,000. Now notice if it's negative, we need to use the negative sign down here, not the minus. So negative $5,000. And the probabilities, we're going to put over here in list 2. So he could win 200. That would be 98%. Or he could lose his whole investment at 2%. And now we're going to calculate one variable stat on these two lists, list 1, list 2. And the mean here is $96. So with investment on bond X, the expected value for X is $96. Now, if I go through the same procedure for bond Y, then, and I put this in list 1, put these values here in list 1, and these values in list 2, calculate one variable stat on list 1, list 2, the expected value for bond Y ends up being $73.75. So which one is a better investment? Bond X, because he can make a little more money on bond X than what he does with bond Y. Anyway, those are a couple of examples of expected value type problems that you might face in your assignment.